right. Okay. So for lesson 10, the first question was, what is a confidence interval? And a confidence interval is an interval of numbers which estimates a population parameter. And number 2, what is a margin of error in a confidence interval when estimating the population mean? The margin of error is half the width of the confidence interval. It's the distance between the point estimator and one of the bounds of the interval. And then the equation that goes with that is m equals z times sigma over the square root of n. The answer key didn't ask, the questions on the answer key didn't ask for the formula, but our prep asked for it. I thought that was weird. Okay, number 3, assuming you know sigma, what is the general formula for a confidence interval used to estimate the population mean? And that's x bar plus or minus z times sigma over the square root of n, or x bar plus or minus 1, or m. Sorry. Okay, 4, what are the assumptions for creating a confidence interval for a single mean with sigma known? You have to have, or the assumptions are, a single random sample was drawn from the population, the distribution of the sample mean is normally distributed, and sigma is assumed to be known. And then for number 5, we had to open the probability applet and go through everything, all the instructions. So A, the answer was 1.65. B, the answer was 1.96. C, the answer was 2.58. And D, what happens with the z-score is the area of the middle, in the middle under the normal curve increases, and that means the z-score also gets higher. So number 6, sorry, I'm on a group text and I keep getting text messages. Okay, what are the 3 assumptions that need to be checked before you compute a confidence interval with a mean? A simple random sample was drawn from the population. The distribution of the sample mean is distributed, and sigma is assumed to be known. And then number 7, the graduate management admission test is used as an admission criterion on admitting Masters of Business Administration programs. The BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. Sample mean for these students is 541, assuming a population standard deviation of 32. Answer the following questions. So number 7, what is the point estimate of the population mean? And I got 541, but I couldn't tell if the point estimate was always the sample mean. Because it seemed like it was the sample mean for this question, but I don't think that's what it is all the time. So maybe
figure it out, or did you just take it from the problem? I just took it from the problem. I didn't know I was supposed to figure it out.
Oh no, you're not. You just take it from the problem.
Okay.
But I was confused because in the textbook it didn't seem like it was supposed to be the population mean, but it was in this case. So yeah,
okay.
We'll get to that later maybe. Okay. 8, create a 95% confidence interval for the population mean. Show your work below. So I got, the 8 was 532.13 and 549.87.
But then they had us round, right?
Yeah. And then for 9, you do the same thing, but with a different sample size. And for 9, I got 534.73 and 547.27. And then number 10, how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of sample size 100? And I got that the margin of error gets smaller as the sample size gets larger.
That's wonderful.
And then 11, create a 90% confidence interval for the original 50 students. And for that one, I got 533.56 and 548.44. And number 12, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you computed in question 11? And I said when the confidence interval goes down, the margin of error goes down. And then 13, the BYU professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval? So with this one, I think if I'm doing this right, you just work backwards. Like you fill in the equation, but you were doing it backwards. And then I got 158 students.
1,000. Wait, what number again? 13?
13.
Yeah.
I got 164.
I got 158.
Unless I used the wrong formula, but I got 164.
The formula that I used was n equals z, I don't know how to look, z times sigma over m, and then you square the whole thing.
Yeah, I did it with the different formula, with the 2 instead of the z-score on it.
I got 158.
That's what's on the answer key too.
No, it doesn't. No, the answer key doesn't have the answer though, unless on my computer. My computer just says students. It doesn't have the whole answer.
Oh, mine does. Sorry. I don't know what to tell you.
Like on the question 9, where you're supposed to use like 100 students instead of 50. My computer doesn't say the number. It just says, say that the sample size changes to, and then it says, now compute a 95 confidence interval. So it took me a while to figure it out. Then I had to read the next question and say, oh, okay, so it was 100, but it doesn't say so.
Are you using Word?
Yeah.
That's weird. It must be a formatting issue. Do you have like an old version of Word?
No, I have Google Chromebook, and it's the newest Microsoft Word.
Yeah, that's weird. I don't know what that's about.
I don't know.
You might want to pull it up on like a different computer when you do the assignment so that you can see all the numbers. Because I can't imagine that you would, like, how can you do it if you can't see the numbers, you know?
The number, yeah. Sometimes the questions are not even finished all the way, and it's not the first time. It's like happens at least 3 or 4 times before.
You know, I have a problem with that in some of my classes. Not necessarily. I've never had it in this class, but it'll be like a reading from a textbook or something, and they post it online. But there's a place to download it. If I don't download it, I'm missing chunks. I didn't get it the first time, but then if you download it and you go back and look, and the chunks will be filled in. I don't know why that is, and I've never had it happen with Word.
But I downloaded all the documents to my computer, and that's how I opened it up.
I don't know then. I am no computer genius.
Yeah, me either. I rely on other people for that kind of thing.
Yes. I do what I can do, and that is all.
Yeah, that's weird. I'm sorry.
That's okay.
Do we feel like we're ready for our quiz?
Yes.
I hope so.
Yeah,
So we're gonna start it, or are we still waiting for Megan? You said 10. It's 10:18.
Yeah, I think she'll come when she can. I think we should just keep working.
I do too, because we could wait for a long time.
Yeah, we could wait indefinitely.
Yeah, I'm gonna start it.
Okay. Okay, so for number 3, it looks like it's the same thing as 8 and 9, I think. So we use that formula, the x bar plus or minus is it z times sigma over n to the square root of n.
Yeah.
You should write Z for 90, not 95.
So for 90%, it's 1.645, right? This threw me off because we've been doing 2. We've been doing 1, 2, and 3, and now it's changed.
On number 5 of the prep work, it does say 90%. That's 1.65.
What?
It's 1.65.
Where did all the noise come from? Wait, what?
Wait, what did you get for number 3?
Well, I don't know. I'm still trying to figure out what X bar is. What's X bar?
Yeah, that's what I was wondering too.
Well, I was thinking that maybe it's the razor
You probably could.
M
Well,
for
it was a stretch.
times
Yeah. That's another 2 practices.
the N.
I can't hear. Megan, can you mute yourself or something? Your background noise is. We can't hear each other.
What's the my?
Yeah, sorry.
Thank you.
Can you hear?
No, now I can hear you, Jennifer.
I was saying maybe you should use the M equals the Z times the standard deviation divided by the N, because you don't know the X.
Yeah, I think you're right.
If you do that, then you get 16.5.
Okay, I'm gonna do it.
Which equation did you use?
Let me show you. On the prep work on number 3, M equals Z times the sigma divided by the square root of N. So, and then if I do that, then right here,
Right?
that's how I did it, and then I haven't written it down, but it's 16.5.
So Z.
Wait, can you show me what numbers you're plugging in? Because I got a different answer. I don't know if I'm doing this right.
Why not? Wouldn't be the Z for the C score? Yeah, the C score for 90%, that is 1.65. And then you put 50, because that's what it says in the thing, and then 25 with N. And then when you're supposed to do 50 divided by the square root of 25, and you times it by that 1.65, and then you get 16.5.
Okay, I think I just wrote the z-score down wrong. Yeah, okay, I did. I wrote 945 instead of 645. Sometimes I think I might be slightly dyslexic.
You're overcoming. Don't worry.
But the thing is, round to 3 decimal places. My calculator only did one place. One decimal place.
Okay, I got.
It would show you though. I think it's just 16.45. So there's no need to round to 3 because there's no third number.
That's what I got.
Unless we just put 2 more zeros, 16.500.
Well, I have 16.45. So I put 16.450.
Unless my calculator rendered it up on its own.
No, that was the answer. 0.45. Oh, you know what, Jennifer? It's not 1.65 for the z-score. It's 1.645.
So you say you got 16.45.
Yes.
So you just put one more zero if you really want 3 decimal places.
Mm-hmm. Okay. I think we're going to need your help, Jennifer, on the next one because you're good at that.
Okay, so it says consensus.
I say C.
Well, I wrote notes, so I'm gonna double check before I say anything.
Or maybe A. I don't know.
I look at the symbols and stuff, and I'm like, I'm going to need 20 minutes to process this question.
Well, I have notes. Let me show you. I wrote it in a little table. I don't know if that helps.
Oh, that's awesome.
That should help with the question. It says which one's true. So mu, I'm guessing, is the mean. So the mean of x. It's on the book.
Yeah. What's the point estimator of U? All right, so what do we decide?
I think it's A. Wait.
I think it's C. But the only reason is because something I wrote down in an equation.
Well, then you're saying it's this one. Let me show you. The first one, then.
Yeah, the C is written in the chart. I think you're right. I think it's C. A is backwards.
So for this one, how I like to have it is that you use the X bar to estimate what the mu is. You determine the X bar through your data, and then you use the mu of the population mean or you find the population mean through finding the sample mean.
X bar is the estimator of mu.
Yes.
Okay. Yay. All right. Are we ready for the next one?
Yes.
Yeah.
For this one, it is the formula that we were talking about earlier. Remember?
Mm-hmm.
Oh, the one where we have the X bar?
Yeah.
Okay.
So 95 is 1.96 for 95%. For Z.
All right.
Did you get it already?
Yeah, but I have that. Remember my awesome calculator? Called eCalc.
Yeah, I can hear it when you're punching things in. I'm always like, how is she already there? I'm still writing things down.
But this is what I got. 498.315.
That's what I got.
I'm still calculating.
Okay, you seriously need to get that the app. It's called eCalc.
eCalc?
ECALC. And you just plug it all in, and it spits out the answer for you.
Well, then I'm going to try to do that then.
And then what I can do now to figure out the other end is you can click on the equation you just put in, and all I have to do, the numbers are all input, and all I have to do is put in the plus sign instead of the minus sign, and spit out the next number.
Wow. I'm going to download it.
I got 498.315.
That's what we got.
Okay, good.
Uh-oh.
And then for the upper level, I got 553.685.
I'm not done with the other one yet.
I'm sorry?
I'm not done with doing the math for the other part.
Oh, okay.
You say you got what again?
For number 6, yeah, 553.685.
Oh, let me try again. I didn't get it right. I probably didn't type it right. $553.685.
Yes.
That's what I got right now.
Yeah, that's what I got. Okay. What happens to the width of the confidence interval if you increase the sample size? Uh, hang on. What is that? It gets smaller. Oh, I'm sorry, it will decrease.
Where did you find that?
I'm
Did we
looking
write?
at, okay, I didn't write it down, but in number 8 of the prep assignment,
Mhm.
in number 8, we did the confidence level of 95% for 50, and then number 9, we did 95% for 100, and the larger sample size makes a smaller confidence, makes smaller numbers in the confidence interval.
Yeah.
Okay.
One way to think about this is that you're dividing by a larger number, and so the number is going to be smaller when you divide by a larger number.
Okay.
Also, you have more of a sample to determine what your mean is. So you have a more accurate answer, so the range will be smaller.
Got it.
Yeah, that makes sense. Okay. Are we ready for number 8?
Yes.
So based on that, what happens to the confidence level if it's 99? Then, based on what Megan just said, then it decreases even smaller, right?
For this one, it would actually increase because when you have to be more confident, you have to have more of a range. Like if you were 100% confident, you'd have to include every number. 99, you get smaller. 95, 90, you're not as sure, so you have a smaller range that you would include.
Oh, okay. I had it backwards then. Okay.
Okay, so 9. Are we ready for 9?
Yes.
Okay. Bright Bulb Light Company is planning a study to assess the average life expectancy of their light bulbs. We know the standard deviation of sigma equals 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Then we need to do like the last question of the prep work.
Yeah.
So, 95.
Okay, so if I'm doing this right, I got 224.
I got 246.
Wait, let me finish mine. I'm almost done.
Okay.
I just need to put the numbers in the calculator. I got 245.862.
That's what I got. So it rounds to 246. What did you put in your equation, Emily?
I did 1.96 times 400 over 50, and then the whole thing squared. I think I may have been doing a order of operations error. Because I did again, I got 245.8624.
That's what I got. So then it rounds to 246.
Okay. Great. Okay, so number 10, the mean salary of actuaries is mu equals $100,000, and the standard deviation is $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with the significance of A equals 0.05. So we want to know what is the lower limit of the 95% confidence interval.
So,
Is this the same equation as before?
I think so.
So they just gave us like tons of extra information for this one.
What?
I got a long number, huge number.
I got $99,001 and 0.5333333
I got 100,929.858333.
But aren't we supposed to use X bar? The equation shouldn't it be the X bar minus the Z score?
Yeah, that's what I used.
Yeah, but so the X bar is 111,000, right? Not.
No. Yeah, I don't know if I did it right, but this is what I did.
All right, Emily, what did you get?
I'm almost done.
Unless I didn't type it right. So I got the wrong answer according to your answer.
Well, I don't know. It's just different than mine. Maybe I'm wrong.
But you calculated.
Okay, I got 99,001.5333.
That's what I got.
Then I probably typed it wrong. Let me
There's
try.
a lot of numbers, so
Yeah, I'm gonna try again. It's 36730 divided by the square root of 36. Then I times it by 1.645, and then I use 1.3 minus.
Wait, what did you times it by? 1.960, right?
No, 1.645.
we're doing a 95% confidence interval, not a 90% confidence interval.
It's 95. So it's 1.960.
That's probably why.
Probably.
I'm gonna try again, but with the 1.960. 36.
So for 10, I just wrote 99002. Do I put a comma in there, or do I just leave it?
I don't think
Don't use a comma.
Okay.
This is showing, but let me show you. I did it again.
No,
No?
it's not. It's 99001.
I mean,
It's
I
it.
typed the right numbers though.
Oh,
I typed 1.9.
okay, show me again. Show me again.
What?
Show me again. I can't. I didn't see. Look at the number. Yeah.
Nope.
The numbers aren't right that she put in the equation?
This is the formula, and then it's supposed to be the answer.
Yeah,
The
that's
answer's not
yeah.
right.
The formula's right. The formula's not right. Is that what you said?
The formula is right. The answer's not.
Okay.
Unless I'm typing them wrong again.
It's okay. So, Carrie, did you do number 11?
Yeah.
I got 122.998.4. Oh, 122,998.4667.
Right. So I'm
So
wondering,
if you,
Go ahead.
do we round it to 122,999?
well, I think so.
So the next decimal is a 0.4, and so because it's not above 0.5, you don't round up. You only round up all the time when you're dealing with people.
Okay.
The next one is 6, so it would round up to a 5 and then a 9.
Yeah, but if you're rounding to the whole number, we just look to the number to the right.
Oh, okay. I didn't know that.
Is that the right one now?
Okay, wait.
After typing it, was it like the
Yes, that's right. Yay!
I feel like we should throw confetti or something.
Oh, 12 is easy.
Yeah, this is right from the homework.
What number are you on?
12.
Already?
Hurry. Well, 11 is just like 10, only with a plus sign, so.
Oh.
For 12, I got D.
D like dog?
Yeah.
Okay, that's what I
Wait,
got.
you get this number for the number 11? This one right here?
Yes, yes.
Okay.
Alright, we can submit. I'll go first. 100%, guys.
Woohoo! Oh,
No.
that's a good feeling.
I'm about to submit. I'm just trying to type the long number.
Okay, that's fine. Take your time.
Okay, I got it. Let's see. Yay! I got 100%.
You look happy.
Okay. So. Number. Or lesson 11. Are you guys ready?
Yes.
Yes.
Okay, so for number 1, I got, it was list the 3 characteristics of the student's T distribution, and it had to be symmetrical, it had to have a mean of 0, and it had to be bell-shaped, and then there were 2 more. The exact shape depends on the degrees of freedom and more area in the tails than the standard normal distribution. And number 2, how many degrees of freedom generally does the T distribution have when it is used for inference for a single mean? So the degrees of freedom equals n minus 1. So the sample size minus 1. And then 3, what is the formula for the one sample T confidence interval? And that was, okay, this is hard to read. X bar minus T. Okay, I can't read that. Hold on. Let me find one that's more legible. Okay, yeah, x bar minus T times S over the square root of n, or plus, so plus or minus. And then, sorry, did that make sense?
Yes.
Okay, number 4, what are at least 2 differences between the one sample T confidence interval and the one sample Z confidence interval we covered in lesson 10? So for number 4, sigma is not known, and we have to look at the degrees of freedom for the T distribution, where the normal distribution doesn't have degrees of freedom. And then there was another one, we compute a t-score from the student T distribution rather than a z-score from the normal distribution. Okay. Number 5, when conducting a hypothesis test for a single mean with sigma unknown, what is the formula used to compute the sample test statistic? And it was T equals the x bar minus mu over S divided by the square root of n. 6, what are the assumptions that need to be met to conduct a hypothesis test for a single mean when sigma is unknown? Simple random sample, it has to be drawn from the population, and x bar has to be normally distributed. And then number 7, we had to we put it in, well, I used Excel. Wait. Yeah. Okay. So I just put in the numbers in Excel, and we had to get the sample mean and the standard deviation. So for the mean, I got 46.73, and then for the standard deviation, I got 8.83.
That's what I got.
Okay. And then we're back to this problem, which we've done before. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients who purchase an investment property and obtains the data shown. So there's the data. And then number one, what are the requirements for creating a 95% confidence t-interval? And it has to be a random sample from the population, and the x-bars have to be normally distributed. And then number two, with the data above, create a 95% confidence interval to estimate the mean age of all the clients who buy the investment property. And then I got 41.8 and 51.6. And then for number three, I think we did the same thing with a different confidence interval, and I got 39.9 and 53.5. And then if number four, you just have to put it in SSPS and compute it through SSPS, and you get the same answers. And then number five, how does the margin of error of the 95% confidence interval compare to the 99% interval? The margin of error for the confidence interval is smaller than a 95% confidence interval, confidence level than a 99% confidence level. Okay. And then number six, for A, it was the null hypothesis is mu equals 47, and then the alternative hypothesis is mu does not equal 47. And then B was I got -0.118. And then for the degrees of freedom, you just do 15 minus 1, and you get 14. And then I sketched it. And then for E, you calculate the p-value. And I got 0.9077. And then for F, you have to decide to reject or fail, and we failed to reject. Yeah, failed to reject the null hypothesis. And then for G, we have to say why we failed, basically. So we don't have enough evidence to conclude that the realtor's mean is different than the national averages. The national average mean. And that's what I got for G. Okay.
Okay, are we ready for a quiz? Did we? Okay, so when when it says to compute the p-value, that's when we use that student t applet thing, right? You put the numbers in that?
Or you put it into SPSS and compute it that way.
Okay, so when I did that, where do I find that number? Because the number that I got didn't quite equal that. It was very close to the answer key, but it wasn't exact. So where's that number at, the p-value number? Can you tell me, Megan?
P-value is the number that's on the significant two-tailed. That's where the p-value would be on SPSS. Is that where you got it?
Yeah, but mine didn't come out quite exactly right.
Mm-hmm.
So yeah, maybe I put one number in off, slightly off. I don't know. I don't have it up right now. So are we going to need? Okay, so that's where it is the two significant, whatever it's called.
Yes.
Okay. All right, are we ready for a quiz, girls?
Yep. So for 3, is it sigma is unknown? Because it seems like that's what we did for this.
Yes.
Mm-hmm.
The known hypothesis. Okay, we're working on 4 and 5, right?
Mm-hmm. So it says that sigma is not known. Are we supposed to do that? Is it an equation?
Yeah, is what you're searching. It's the equation from number 5, I believe, on the prep assignment.
Are we on number 5?
We have 4 and 5. All right. Anybody can answer?
I'm still working on it.
Is your calculator eCalc 2.0?
I don't know. It may not be the most recent version because I got it a couple semesters ago when I was taking a different math class.
Wait, so for T, I got 1. Is that what
I
you
got
got?
1.5.
Okay. So for my equation, I did the x bar minus n over s divided by the square root of n. Is that the formula you use?
Say it again, x bar minus.
Minus n, oh, u. Wait, oh no.
Well,
I just
U is
wrote it. I wrote it wrong.
U is H, right?
Yes. Did you get the answer, Jennifer?
I'm not done yet. I'm using the calculator. I'm plugging the number. I got 3 over 2. That is 1.5.
That's what I got.
Yeah, me too. Okay, for number 4, sigma is not known, right?
No, it says right there, sigma is not known.
Well, I thought it might be a trick question.
It did trick you.
So for
Okay.
number 6, we're using all those numbers and just copy and paste it to the program, right?
Mm-hmm.
That's what it says. What is the x bar?
But it doesn't let me copy and paste it now. What are we looking for? X bar?
X bar. All right, did you get answers?
Not yet. Okay, I got 98.22.
That's what I got.
For what?
The 6.
I mean, it's the X bar, right? What are you looking for?
Right.
We're looking for the X bar from that one.
I can't hear you, Jennifer. What?
Mine is not showing the X bar, it's just showing the T and the difference DF, the mean, the lower upper. Let me show you. Let me share the screen in a second. Let me share right here. Watch. America's mine is different than yours. Mine is Apple. See what?
It's your mean. See where it says mean 98.22 at the top of the descriptives box?
Right here? That?
Yes. Yes.
Oh. So I
That's
was looking over here where it says what? Where did it go? I moved. Right here it tells me the T and the difference and all that stuff. Alright, I mean, never mind.
what is it?
Okay, so I think I got number.
S stands for sigma, right? Oh, for what?
It stands for the sample standard deviation.
Okay.
For S, I got 0.922012.
That's what I got.
Okay.
0.92201?
012. So it's just 0.922.
For this score is 476.407.
What?
For the next one, number 8.
Okay. What did you get?
476.406.
I got a negative 1.843.
Did you type in the test value of 98.6?
Yeah.
Maybe you didn't copy the numbers. I don't know, because
That's really high.
yeah.
That's like the same numbers for the other numbers that we got, the mean and the, what is it called? The other ones that we just got for the other questions. I'll try again. I'm gonna check again. Oh, you said negative 0.1843?
Yes.
Yes. I got that now.
Did I say 0.843? Yeah, that's what I said. Okay, so for the p-value, and this is like getting stuck.
Yeah.
So the p-value, you do in the SPSS, it's the sig two-tail thing, and so in this one it says 0.081. Is that correct, Megan?
This is a one-tailed test. We're doing less than 98.6. So we'll just divide it by half.
Okay. Right.
But what button do you push to get the tails, though?
It's in the you do analyze, and then you do compare the means.
And then the T
Sample.
sample.
One sample T test.
And then you still put 98.6 though, right? Because that's what we're doing.
Yes.
I already did that.
And then it's the number in between the DF, the degrees of freedom, and the mean difference. It's the
Okay.
sig two-tailed.
0.081, and then you divide it by 2 because this is two-tailed.
Because it's one tail. Okay, I understand. That's the part I was struggling with. So the answer is 0.041. How you doing, Emily? Did you get number 8? Or did you?
I think so.
You look kind of worried.
Well, okay.
You say you got 0.081?
Yeah, but divided by 2.
Then it's 0.041.
Yes. Okay, Emily, what are you stuck on?
So for 8, wait. Okay, I'm sorry. I am using Excel and not SSBS. Don't get mad at me. And so it's like I was trying to figure that out, how to do it on Excel.
Well, to find the t-score, I just put it in the equation. The one that's x bar minus mu over s divided by the square root of n.
Oh.
I don't even know. I'll look and see. Oh, but it's there. It's 1.843. It's in the. Oh, you're using Excel though. I don't know how to do it in Excel. Sorry.
I think answers may be different if you use Excel as well. So I'm not sure about how that works.
Well, you need to put the same answer though for the quiz though, right? Even if you use Excel.
done it. I don't know. I've done it in Excel before, and I did get the same answers. I'm just doing it on a different computer than I have SSPS on, so everything's already up, and I was like, I don't want to pull it up because it makes a bunch of noise because the printers always turn on at the same time when I draw on this computer.
Well, figure the t-square by hand if you can, because all the information is there, right? Not by hand, but you know, by calculator.
Right. Okay. I'm holding you guys back.
We're helping you. It's not holding back.
I took forever last time for the last lesson, so we can wait for you.
Okay, so for number 8, I got negative 1.8431, and then there's a whole bunch of numbers.
Yes.
Okay. Well, I got that. Great.
So now can you do the p-value? Can you see the p-value in Excel?
I don't know. I don't remember how to do it.
I really don't know the answer to that one. Sorry.
It's okay. Okay, did we, for number 10, did we,
Reject the null. Well, because did you find your p-value?
no.
I got 0.041 for the p-value. What did you get, Jennifer?
For number
9.
10?
Number 9.
9? 0.041.
Okay, that's what I got. So that means that because it's less than the, what is it called? The little a thing. Oh, the level of significance, because it's less than that, that we reject the null.
Yep.
Are we ready to move on to number 11?
Yes.
How about you, Emily?
Yeah, I'm gonna pull up SSPS now, so everything will actually make sense to me.
Well, at least that we know how to use that. Well, that was the one I'm understanding anyway.
I need to start heading to my next class, but I'm gonna switch over to my phone so I can still be with you guys. But
Okay.
hopefully this works.
Ooh. I have to go down and get my power cord because I'm out of power, so I'll be back in just a second.
Okay.
Where's the P word?
So instead of putting the 95%, we put 0.01 for the level of significance, right?
Yes. So for 11, is anybody getting an answer yet?
Okay.
Okay.
How come I got the 0.000 for the p-value?
I don't know. I got .995. Did you copy and paste the numbers in?
Yeah.
Okay. And then you look at the box that says sig dot two-tailed in parentheses.
Yeah. You want me to show you?
Sure. I don't know that I can. I'll look at it. But I don't know I can do anything about it.
I know. It's not the same. Right here. These are all the numbers, 59 to 61.
Okay.
Then I did this one,
Right.
option 0.01.
Okay. Wait. Your test value. Your test value needs to be 40.
40?
Okay. 40. Now what'd you get? There it is.
0.995.
That's right. Well, that's what I got anyway.
That's what I have as well.
Okay. That's cool, Megan. You can be on there and walk into class. Emily, how you doing?
Good. I'm putting in the data into SSVS, so I will be there in a second.
Okay.
Are we supposed to divide it by 2? Because this one was 2 tails instead of 0.995. It's divided by 2.
Well, we don't have to divide because it's two-tailed. This is the way I understand it. Because it's two-tailed, because it's because the hypothesis is either it is or it's not, so it's the equal sign with a line through it. It's two-tailed. But if it had a greater than or a less than sign, then it's one-tailed. So this one we don't have to divide by 2.
So greater than or less than, that's 1, right?
That's one-tailed. That's the way I understand it.
That's exactly right.
So it is 0.995.
Okay, so I still haven't done number 11 yet.
Number 11. Oh. Well, all you got to do is plug your copy and paste your numbers into SPSS and then look and see what the p-value is. You know how to do that?
No, where would it say the p-value?
Okay, so have you got your numbers plugged in?
Uh-huh.
Okay, so then go to the top and it says analyze. And then the third one down is compare means.
Okay.
And then one sample t-test. And then it should pop you up an output box that says one sample test. And the p-value is the third box over that says sig and then two-tailed in parentheses. Do you see it?
No. Here, let me show you what it looks like. Can you see that? Oh.
Oh, I know what. I know what you need to do. You need to put the variable in, and then when it says test score, there's a little box that says test score. Put in 40. And then hit OK. Is it 40? Yes, 40.
Okay.
Now do the. You should
Came up with a big box with a bunch of, like, a couple of graphs and a bunch of numbers.
Okay, scroll down. Is there one that says, what does it say? Hold on. It says one sample test.
Uh-huh.
And then is there a box that says, one says T, one says DF, and then one says SIG with two-tailed in parentheses?
Yeah.
SIG is your p-value. I wish it said these p-values, but it doesn't. So what did you say?
0.995?
Yes.
Oh, wow, that was way easier.
That's why I like this program. Plus, in the book, it tells you, like, step by step how to get the answer you want.
Oh, okay. I just, like, have always used Excel, and so I didn't want to figure it out.
The book will tell you exactly, like, push this button, and then this button, and then this button. Or whatever. Okay, so 12.
So if the p-value is 0.995, wait, it doesn't give us a.
For number 12, I got failed to reject the null hypothesis.
Right. In 11, it says the level of significance is 0.01. So that's our A, and so it's greater.
Oh, that's right. It does say that. Okay.
So I failed to reject the null hypothesis?
Right. That's what I put.
Because I thought if it's bigger than 0.05, then you keep the null hypothesis, so you fail to reject it.
Right, but in this case, it's 0.01. 0.01. Okay, and then it says, for 13, decide to try another hypothesis. This time, the alternate hypothesis is mean is less than 40%, and you keep the same level of significance. So then we just take the same p-value and divide it by 2. At least that's what I did. And so does the p-value decrease or increase or decrease? And I put decrease.
And then you put 14, you reject the null hypothesis because it's
still too big.
Yeah, that's what I mean. But you put reject the null hypothesis or reject?
Yeah.
Fail to reject?
No, fail to, because it's still too big for 0.01.
But what in the question says, oh, never mind, I see it. And then question 15, compare the width of the confidence interval. Question 11 is 0.995, and in question 13 you decreased it. So still.
What did you use to figure the confidence level? Because I'm not exactly sure. Our confidence interval is.
So for this, you don't actually have to calculate the confidence interval. They're just asking of whether or not what the confidence or how that changes between the two problems.
But okay, so I said I would think that they stayed the same because you use the same information that the output box gave you, except for dividing that p-value in half.
And that's right.
Okay.
You've got it, Emily?
Yeah, I think I have it.
Yeah, I'm gonna submit it.
And then just to clarify, what did you guys get for 12 and 13? Or 12 and 14?
Fail on both.
Okay, just making.
Yay! We got
Okay, are we ready to submit?
I already did it. It's 100%. We got it all right.
Yay!
Do you guys have any other questions?
No, I think, well, I feel okay. Emily looks a little confused.
I'm gonna have to look at this some more.
Okay. If you guys do need any other help, feel free to email me or come into my office hours and that kind of thing, because I'm here to help you guys. I want you guys to always do well.
All right, thank you, Megan.
Thank
Thanks
you.
for
No problem.
coming.
Yeah, no problem. Sorry I was a little late.
It's okay.
Sorry it went so long.
No, it's all
Emily?
good.
Emily, do you have questions that we can talk about, or do you want to just confused overall?
No, I think I mostly got it. I'm not exactly sure. Hold on. Number 13. How did you know to divide by 2?
Because Megan said so, and well, she said when it's two-tailed, because if you look at that box, it says sig two-tailed or whatever. When it's two-tailed, it's the hypothesis has that equal sign with the equal sign and then equal sign with the line through it. But if it's got the greater than or the less than, then you're only having one tail on your little bell-shaped curve.
Exactly.
Oh, that's right. That was from last week.
So you have to divide it in half to get the right probability or p-value.
Yep.
Okay, yeah, that makes sense.
Does that help?
Yeah, I think I got it. I was just slow.
Do it in SSPS.
Yeah, I will from now on because that makes a lot more sense.
And they gave you the answers.
Okay. Anything else, girls? We've been on a long time today.
Yeah, I'm good. I'm gonna stop the broadcast.
Okay.